Hey guys, welcome back to my channel GB Stories. So today we will continue with the generators in parallel problems. So the second question is that the alternator is rated for 750 kVA at 0.85 power factor. What is the maximum load that can be put on it? Would you be overloading the alternator if the kilowatt reading were now 620 kilowatt and the power factor is 0.80? Okay, so let's solve this problem. They're saying that the alternator is rated for 750 kVA at 0.85 power factor. So there is an alternator solution. There is an alternator. Consider it as A. Okay. So it is having a kVA, that is apparent power. kVA is equal to 750. Okay. And the power factor, that is power factor, which is the cos phi. Cos phi is equal to 0.85. Okay, what is the maximum load? So they are asking what is the maximum load. They are asking what is kilowatt. Kilowatt equal to how much that can be put on it. So they are asking what is the maximum load, so they want the kilowatt. So let's find the kilowatt. We know the formula, cos phi is equal to kilowatt divided by kVA. So I have discussed this formula in the previous video. You can check it there if you don't know the formula. So cos phi we know, that is 0.85 is equal to kilowatt divided by kVA, that is 750. So kilowatt equal to 750 into 0.85, 750 into 0.85, that is 637.5. Okay, so the generator can take 637.5 kilowatt, the maximum load this generator can take. Next they are asking, would you be overloading the alternator if the kilowatt reading were now 620 kilowatt and power factor is 0.80? So they are asking, if now the kilowatt is equal to 620 kilowatt and the power factor is equal to 0.80, would you be overloading? So to check that loading, okay, to check that we can find the kVA. We should check the kVA. If kVA is greater than alternator A kVA, then we are overloading. If it is less, then the alternator is not overloaded. So how to find kVA? We know the formula, cos phi is equal to kilowatt divided by kVA. So kVA is equal to kilowatt divided by cos phi. So we know kilowatt is equal to 620 divided by 0.80. So kVA equal to 620 divided by 0.8, that is 775. So see, alternator A kVA is how much? 750 kVA. Okay, now the answer which we got is 775. It is greater than the alternator A kVA. So of course the generator is overloaded. So they are asking, would you be overloading the alternator if the kilowatt reading is now 620 kilowatt and power factor is 0.80? Yes, the generator is overloaded. Overloaded. Hey guys, so we'll continue with the third problem. So the third problem is of transformer, but the method is same as the generators in parallel. So I'll do this problem in this part itself. So the question is, a 72 kVA transformer supplies a heating and lighting load of 12 kilowatt at unity power factor and a motor load of 70 kVA at 0.776 power factor. Calculate the minimum rating of the power factor improvement capacitors which must be connected in the circuit to ensure that the transformer does not become overload. Okay, so they're saying that there is a transformer of 72 kVA. Okay, solution. There is a transformer of 72 kVA. Okay, so it is supplying a heating and lightning load. Okay, of 12 kilowatt at unity power factor. So there is a heating and light load. Okay, so what is a kilowatt? That is a 12 kilowatt. So let's write kilowatt here. It is 12. Next one, at unity power factor. So power factor, that is the cos phi, that is at 1 unity. Okay, next one, a motor load of 70 kVA at 0.776 lagging. So there is one more load, that is the motor load. Okay, so that is at 70 kVA. So let's write kVA here. Okay, so that is 70 kVA. Okay, and power factor is 0.766. Okay, so let's write the remaining terms also, that is kVAR and the sin phi. Okay, let's find out the values now. Okay, so let's first total. Okay, total load. Heating and lighting load, kilowatt is 12, power factor is 1. So we can find the sin phi. So we know that, I'll write H and L, that is heating and lighting load. So we have given the kilowatt. Kilowatt is equal to 12. Okay, cos phi is equal to 1. So sin phi is equal to root of 1 minus cos square phi, that is equal to root of 1 minus 1 square, that is equal to 0. Okay, so we got sin phi is 0. Okay, now to find kVA, how to find kVA? We know that cos phi is equal to kW divided by kVA. Okay, so kVA is equal to kW, that is 12 by cos phi, that is 1, is equal to 12. Okay, we got 12. kVA is 12. Okay, now kVAR. So we know that sin phi is equal to kVAR divided by kVA. Okay, so we know that kVAR is equal to sin phi into kVA. Oh, we know that sin phi is 0. 0 into kVA is equal to 0. So kVAR is 0. Okay, so we found out the heating and lighting load, all the loads we have found. Let's go to the motor load. Then right here, motor load. Okay, that is a motor load. Okay, now coming to motor load, what is given here? Cos phi is given. Cos phi is equal to 0.766. Okay, we can find the, and kVA is given. kVA is equal to 70. Okay, we can find sin phi by the same formula. I'll not write the formula here. We know the formula, 1 minus cos square phi. So root of 1 minus cos square, we know 0.766 square. That will be 0.6428. Okay, we got sin phi. Let's write it here. Sin phi, that is 0.6428. Okay, next we have sin phi is done. After sin phi, we have we can find kilowatt. So we know that formula, cos phi is equal to kW divided by kVA. So kW is equal to cos phi is 0.766. So kW, sorry. So kW is equal to cos phi is 0.766 into kVA, that is 70. That is equal to 0.766 into 70. That is none other than 53.62. Okay. So let's write it here, kW, that is 53.62. Okay, got it. Okay. Next one, kW we find. We have to find kVAR. We know that kVAR, okay, that is equal to sin phi into kVA into kVA. This formula we are using, same formula. So kVAR, sin phi we know 0.6428 into kVA, that is 70. That will be equal to 0.6428 into 70. That is another than 44.9960. Okay, that is 44.9960. Okay, so we have found out the values of all these values. Now let's find the total load. What is the total load? Okay, total load we can find out. Okay, so now find out the total load. Total load. Okay, so let's find total load. So we know kilowatt of heating and lighting is 12, motor load is 53.62. Let's add this. We know the formula, that is kilowatt A plus kilowatt B is equal to total kilowatt. That is 12 plus 53.62. That is 65.620. Okay. So we got the total load at 65.62. Okay. Next one, we can add kVAR, that is kVAR A plus kVAR B is equal to kVAR total. So this is 0 plus 44.9960, that is same as 44.9960. So total load, now remaining parameters we have to find, that is the kVA, sin phi and cos phi. So we know that, let's draw the triangle for easier explanation. Okay. We know this is kilowatt, that is 65.62. Okay, it is a real power. We know kVAR is here 44.9960. That is the apparent power. This is the reactive power, that is Q. So we have to find kVA. kVA is S. So by Pythagoras formula, kVA is equal to root of kW square plus kVAR square. So what is kW? kW is none other than 65.62 whole square plus 44.9960 whole square. Okay, that will be equal to root of 65.62 whole square plus 44.9960 whole square. That will be none other than 79.5652. Okay, so we got the kVA of total load. Total load kVA is 79.5652. Okay, we got all the parameters. So let's move to the next question. Power factor and sin phi is not needed. These parameters are enough. Let's move to the next question. What they are asking: calculate the minimum rating of power factor improvement capacitors which must be connected in the circuit to ensure that transformer does not become overloaded. So they're saying that what capacitors has to be added to the transformer so it will not be overloaded. Let's check how much transformer is providing. We know that transformer is providing 72 kVA. 72 kVA is transformer. Let's write here. Transformer is 72 kVA. Okay, So what is the total kVA here? Total kVA is 79.5652. So total kVA that is 79.5652 kVA. So it means that the transformer is now overloaded because the kVA is greater. So they are asking what has to be added to the transformer so that this load can be compensated, that even if it is overloaded, how much capacitor has to be added so that the transformer will not become overloaded. So to do that, to find that value, let's draw the triangle. Okay. Okay. This is a triangle. Okay. So what is this is the right angle, this is the phi. So we know that the real total kilowatt is 65.62. So this will be 65.62. That is the total kilowatt. Okay. Next, what is kVA? kVA is none other than 79.562. This is the total kVA. Okay. Next one, what is the kVAR? kVAR is none other than 44.9960. This is the kVAR. Okay. So this is the total load. They are asking for 72 kVA transformer what has to be added so it is not overloaded. How much capacitor has to be added so it is not overloaded. So now the transformer is overloaded. So kilowatt so which two parameters can be decreased so that the transformer will not be overloaded? It means that should we decrease kVAR or should we decrease kilowatt so that the transformer will not be overloaded? Any two parameters if we decrease, the transformer will not become overloaded. Or else what to be added, what capacitors have to be added so that the transformer will not be overloaded? Let's consider this is the parameter. So let's draw one line. So this is 72 kVA. Okay. This is a transformer when it is not overloaded. Okay. This is 72 kVA. So we have to find how much is the kVAR. How to find this value? We have to find this value. Okay. How much is the kVAR? This is the x value. To find this value, we can use the Pythagoras formula, that is 72 square is equal to x square plus 65.62 square. So x is equal to root of 72 square minus 65.62 square. Okay, that will be none other than 72 square minus 65.62 square. That is 29.6313. Okay, this is kVAR. Okay, so this x is 29.6313. Okay, so we got if the transformer is 72 kVA, so it can take this much kVAR without getting overloaded. So how much has to be added? This has to be added. How much capacitor has to be added so even it can withstand if it is overloaded? So to find that kVAR, that is 44.9960 minus 29.6313, that is equal to minus 44.9960 minus 29.6313, that is 15.3647 kVAR. Okay, so it says that reactive load can be maximum 29.63 kVAR for transformer of 72 kVA. Okay, so we have to add capacitor of 15.3647 kVAR to withstand the transformer so that it does not get overloaded. Okay, I hope you got this problem. So this is a solution how we found out. Okay, so let's go through it. If you have any doubt, you can put it in the comment section. I'll explain it again. Thank you. Okay, let's move to the next problem, fourth problem. They're saying that two three-phase alternators operate in parallel. The rating of A is 1000 kilowatt and B is 800 kilowatt. The droop setting of G generators is 4%. If the load to be shared by both the generator is 1000 kilowatt, calculate the load by generator A and B if the original frequency at no load is 62 Hertz. Okay, this is a droop formula problem. So before doing this problem, let's write down the droop equation. So solution. Okay, droop equation that is F naught minus F is equal to P divided by P rated into droop percentage. Okay, so here F naught is no load frequency. Okay, F is the operating or the original frequency. Okay, P is the output power of generator. Okay, P rated is the rated power of generator. Okay, let's solve the problem now. So they're saying two three-phase alternators operate in parallel. The rating of generator A is 1000 kilowatt. So first one is generator A. Okay, so the rating of A is 1000 kilowatts. So they are giving the rating, that is the power rated of A generator, that is equal to 1000 kilowatt. Okay, next one, generator B. The rated power of generator B is 800 kilowatt. P rated B is equal to 800 kilowatt. What is given in the question. Now, the droop setting of each generator. So the droop setting, that is a droop is equal to 4%. So 4% is equal to 4 by 100, that is equal to 0.04. Okay. Next, if the load to be shared by both generator is 1000 kilowatt, so the output load, that is the output power that has to be shared by both generator is 1000 kilowatt. So they are saying PA, that is the power of generator A plus power of generator B, is equal to total 1000 kilowatt. So it is sharing total 1000 kilowatt. Okay. Calculate the load by generator A and B if the original frequency at no load is 62 Hertz. So they're saying to calculate this value, calculate the load of generator A and B if the original frequency, that is the F, is equal to 62 hertz. Okay. Okay. Let's find the power total load of generator A and generator B. So generator A. So what is the droop equation? We know that droop equation is F naught minus F is equal to P divided by P rated into droop percent. F naught. F naught is no load frequency. Okay. I'm sorry. Here it is given if the original frequency at no load, it means that the no load frequency, this is F naught, not F, not the original operating frequency. The original frequency at no load, this is the no load frequency, is equal to 62 hertz. So by the formula, F naught is 62 minus F is not given, the operating frequency is not given, is equal to PA. PA is not given, that we have to find out. Rated power of generator A is 1000 into droop is 0.04. Okay, let's keep this as first equation. Now generator B, same formula will apply. 62 minus F is equal to PB divided by rated power is 800 into 0.04, generates equation 2. So from equation 1 and equation 2, 62 minus F and 62 minus F is same. So we can equate both equation, that is PA divided by 1000 into 0.04 is equal to PB divided by 800 into 0.04. Okay, so we can cancel this 0.04 and 0.04. Okay, now PA divided by 1000 is equal to PB divided by 800. Okay, we can cancel these zeros, 0 cancel. PA is equal to PB into 10 divided by 8. Okay, so PA is equal to 10 by 8. So it will be 10 divided by 8. That will be 1.25. 1.25 into PB. Okay, let's keep this as star. Okay, so let's go back to the first here. So here it is written PA plus PB is equal to 1000 kilowatt. Let's equate the star in this equation. Okay, okay, now we know that PA plus PB is equal to 1000. Okay, what is PA? PA is 1.25 of PB plus PB is equal to 1000. Okay, so 1.25 plus 1, that will be 2.25. 2.25 PB is equal to 1000. Okay, PB is equal to 1000 divided by 2.25. 1000 divided by 2.25. That will be none other than 444.4444 kilowatt. Okay, now PB we got, we have to get PA. So we know that PA is equal to 1.25 times of PB from equation star. So 1.25 into 444.444, that will be equal to into 1.25, that will be equal to 555.5556 kilowatt. Okay, so this is the answer. So total load of generator A is 5555.5556 kilowatt. Generator B is 444.444 kilowatt. Okay, so first we should know this formula. F naught minus F is equal to P by P rated into droop. So P rated is given, P B rated is also given, droop is given. So total load shared by the generator is 1000 kilowatt, that is PA plus PB is equal to 1000. So see this, the original frequency at no load. So this is a no load frequency. So f0 is equal to 62 hertz. Equating both the equation, putting this in the formula, generator A, generator B, equating this, we'll get this equation, and finally PB and PA we got. So this is the answer. Thank you. If any doubt, if you can put it in the comment section.